Hello everyone and welcome to the chapter number 36 of Blender Master Course Geometry Nodes Creating a House. In this chapter, we'll be understanding all these topics in complete detail and we'll be using them to create this simple looking house in Blender. And yes, if you are new to this course, then do check out the previous 36 chapters from the link of the playlist in the pinned comment. So the first topic of today's chapter is understanding the raycast node. For this, I'll first open the Geometry Nodes editor from here, and to understand the raycast node, I'll first delete this cube by pressing X, and we'll be adding a Suzanne or the monkey model. So press Shift plus A, go to Mesh and select the monkey model. Now to work on the geometry nodes with this monkey selected, go to the Geometry Nodes editor and click on this new button. And also I'll be adding a plane in my scene by pressing Shift plus A, going to Mesh and selecting the plane. Let's move it upwards by pressing G and Z and place it over here. So now we have a Suzanne model and a plane placed over it. Now to use the raycast node, go to the Geometry Nodes editor and click on this new button. And before using the raycast node, we'll first subdivide this plane to see the changes in a better way. For this, go to the Geometry Nodes editor and we'll be adding the subdivision mesh node. So press Shift plus A, go to Mesh and in operations, select the subdivide mesh. Let's place it over here. Now we have applied the subdivision to the mesh. Now suppose you want that instead of the vertices of the plane, you should be seeing some instance object such as a cube. For this, we'll be adding the instance on points. So press Shift plus A, go to instances and select instance on points. Let's place it here, and to place the cube at the position of the vertices of the plane, we'll add the cube node. So press Shift plus A, go to Mesh and in primitives, select the cube. Let's place it over here, and to connect it to the instance, take this mesh socket and connect it to the instance socket. Let's reduce their size to see them properly. So go to the scale option here, select all three, and let's change it to something like 0.5 or 0.4. And here you can see that now we have these 9 cubes placed as instances on the vertices of the plane. And suppose you want to increase the number of these cubes, for this you can go to the subdivide mesh and increase the levels from here. Let's further reduce their size so that we can increase the number of these cubes even more. So go to the scaling again and let's change it to 0.1 this time, or maybe 0.2, and increase the level from here. Now the levels in the subdivision is set to 4, and it looks as if we again need to reduce their size so that they're properly placed. So go to the scaling option again, select all the three, and let's reduce it to 0.1 or maybe 0.08, and this looks perfect. So we simply added a plane, and to place these cubes on the vertices of the plane, we added this instance on points and connected the cube to the instance. Then to control the number of these cubes, we used the subdivide mesh. But the main reason for doing all this was to understand the raycast node. So we'll add it here by pressing Shift plus A, going to geometry, and in sample, select the raycast node. Let's place it over here, and this is how the raycast node looks. Now as the name suggests, it basically casts rays from one object to another. So suppose I want that the rays should be casted from the cubes of the plane onto the Suzanne model. So in this case, the target geometry that you can see here will be the Suzanne model. As a result, I'll go to the scene collection, left click on the Suzanne model and drag it over here. Now here is the object info node with the Suzanne model selected, and we'll connect it to the transform geometry. So take this geometry socket and connect it over here, and now here you can see that we have some output options, and the first one is named is hit. And to view how it works, we have to take this socket and connect it to the selection socket of the instance on points, and here we see some changes. Now as I already told you, the raycast mode will basically cast the rays out of the different cubes towards the monkey object, and with this is hit option selected, it will only display those cubes whose rays will actually reach the target object, which is the Suzanne. To understand it properly, go to the top view by pressing 7 on the numpad, and if I zoom in and turn on the relative option here in the object info node, then now you can see that only those cubes are visible which are aligning with the top structure of the Suzanne or the monkey model. To understand it in an even better way, go to the front view by pressing 1 on the numpad. Let's zoom out, and here in the toolbar you can see that I have this annotate option. So I'll select this, and if I hold the left mouse button, then you can see that I have an option of annotate line. So I will select this, and yes, whatever steps I'm doing right now, you don't need to repeat them in your file, as I'm doing this only for explaining it to you. And here you can see that if I zoom in and let's adjust the view properly, then here you can see that if I draw this line, then it will fall on this monkey object. Similarly, this is also true for all the other cubes that are visible right now. And if I change the view to the side view by pressing 3 on the numpad, then here also you can see that if I draw a straight ray out of the cube, then it will fall on the surface of this monkey. But if I break the connection in between the raycast and the instance on points by holding the control button, right clicking and dragging like this, then some more cubes are visible. But if I draw a ray out of it, then you can see here that this ray is not touching the Suzanne or the monkey model. Similarly, if I go for this one and make a ray out of it, then this one is also not touching the Suzanne or the monkey model. And this was the reason why when I was using this raycast node, these particular cubes were not visible. If I connect it again using the is hit option, then you can see that they will disappear. So in simple words, you can say that by using the raycast node, you will be able to see only those cube objects whose rays will reach the target object, which is the Suzanne. Now for deleting these annotations, again I'll go to the toolbar, hold down the left mouse button on the draw draw tool and select the annotate eraser, then left click and drag to remove it. And now let's go back to the select mode. So we just learned about the is hit socket, and the next one that is available here is the hit position socket, and you can use this to place these cubes on the surface of the Suzanne model at those points where the rays hit the Suzanne model. To understand it better, we'll be adding a set position node after the subdivide mesh node. So press Shift plus A, go to geometry, and in the right category, select the set position node, and let's place it after the subdivide mesh node. So if I take the hit position socket and connect it to the position socket of the set position, then here you can see that these cubes will get placed on the surface of the Suzanne or the monkey model. And now we can use the same method to make the rooftop of a house. For this, we'll be adding a cube in the scene. So press Shift plus A, go to mesh and select the cube and place it over here. Press G and X to move it in the X direction. Now Blender gives you an option to assign the geometry nodes of any object to some other object. For example, the geometry node system of these cubes placed over the Suzanne model is saved here with the name of geometry nodes.001. And if I select this cube, click on this new button, and then if I click on this icon, then here you will find the list of all the geometry node systems that are present in the scene. And if I choose the geometry nodes.001, then this particular node system will get applied to the cube. But the reason why we can't see anything here is that in the geometry nodes editor, the target geometry of the raycast is connected to the object info node, which is carrying the information about the Suzanne model. To connect the cube here, I will first delete this object info node by selecting it and pressing X, and then I'll take this group input, which is carrying the information about the cube that we added, and connect it to the target geometry. Now you can see these small cubes placed here because of the recast node and the instance on points, but suppose you want to see the actual cube. For this, I'll break the connection in between the group input and the raycast, and then I'll take this geometry socket of the group input and connect it to the group output. And now here we have the cube back in the scene. And now to give it a simple structure of a house, I'll tab into the edit mode, press 3 for the face select mode, and then I'll select the top face. To make the basic rooftop, I will extrude this face by pressing E, and let's move it in the Z direction like this. Press S to scale it down. Let's move it slightly downwards by pressing G and Z, and here it looks perfect. Now let's come out of the edit mode, and to see the effect of the raycast node, I'll take this geometry socket and connect it to the target geometry of the raycast node, then take this instances and connect it to the output. And now here we have the cubes placed as instances on the rooftop and the base of the house, and you can control the number of these cubes from the level in the subdivide mesh. Here I've set the value of level to 1, and it appears like this right now. But in order to make the rooftop, we need to make some roof tiles like this, and since its shape looks semicircular, so I'll be adding a circle in my scene and will delete it by half. To do this, let's go to the top view by pressing 7 on the numpad, press Shift plus A, go to mesh and select the circle, press G and X to move it here, tab into the edit mode and press 1 for the vertex select mode. And now we'll delete the bottom half of it. So select these vertices by left clicking and dragging like this, and press X to delete. Select delete vertices, and now to scale it down, we first need to place our 3D cursor over its pivot point, and for this, first come out of the edit mode, hold on Shift plus S, and the snap menu will appear, and select snap cursor to select it. And now here we have the 3D cursor placed over this point. Let's again enter the edit mode by pressing the tab key, and now to scale the circle around the 3D cursor, we have to change the pivot point from this icon to the 3D cursor. So I'll select this, press A to select all the points, and to scale it down, press S and Y and scale it down like this. Left click to finalize, and now to make the complete tile, we'll be extruding them in the Z axis. So press E and Z and move it upwards. Left click to finalize. To view it properly, let's rotate the object properly. So press A to select all the vertices, press R, and we'll rotate it in the X axis. So press X, and if I move my cursor, then you can see here that instead of rotating about its center, or basically the median point, it is now rotating about the 3D cursor. This is because in the pivot point option here, we have selected the 3D cursor, and to rotate it in X axis by 90 degrees, press R and X and type 90, press enter to confirm, and this is how it looks. In order to give it some thickness, let's come out of the edit mode, go to the modify properties, click on add modifier, and in the generate, select the solidify modifier. So you can control the thickness from here, and if I increase it, you can see that the thickness will increase outwards, and if I reduce it, the object will get thickness inwards. And here at a value of somewhere near minus 0.168 meters, it looks fine. And now we'll be replacing the cubes that were present at the rooftop with this roof tile that we created. For this, select the cube in the scene collection, and here in the geometry nodes editor, I'll delete this cube node by selecting it and pressing X. Then to add the roof tile here, select the circle in the scene collection, left click and drag it here. And now we we can connect it using the geometry socket. So I'll take it and connect it to the instances, and now here we have the roof tiles in place of the cubes here. Now the rotation is not correct, so we'll be fixing it later on, but in order to see both the roof tiles and the house together, we'll be adding the join geometry node. So press Shift plus A, go to geometry and select the join geometry. Let's place it over here and connect the group input to the geometry socket. So here we have the house with these roof tiles placed as the instances. Now if you remember, we added a plane above the Suzanne model to cast the rays on it in order to place the instances. Similarly, for this house also we'll be adding a grid or a plane in order to place the roof tiles. To do this, go to the geometry nodes editor, press Shift plus A, go to mesh, and in primitives select the grid. Let's place it here, and to view it, hold on Ctrl Shift and left click on the grid. And now here we have the grid added in the scene. And now to scale it up, we'll use the size options here in the X and Y axis. So I'll select both of them and let's increase it to something like 3 or 4. And to move it upwards so that it's above the house, we'll be using the transform geometry node. So press Shift plus A, go to geometry, and in operations select the transform geometry. Let's place it over here, and you can use the translation in the Z axis to move it upwards. Let's keep it to a value of somewhere near 3, and this is how it looks. Now to give it some more vertices, you can use the vertices option here, and to see those vertices, click on this drop down arrow, and in the geometry section, turn on the wireframe. Now here you can see that we have 4 faces, and if I go to the vertices option here and increase the vertices in the X and Y axis to something like 10, then now the number of faces and the vertices will increase like this. Now since we have basically subdivided our plane by using the vertices option here, we no more need the subdivide mesh node. So I will select it, and to remove it from here, hold down Alt, left click and drag it away. And now to see the house with the roof tiles placed according to the rays coming out of this plane, we have to connect the geometry socket in the transform geometry node to the geometry socket of the set position node. And in order to see the result, I'll select this viewer node, press X to delete it, and now here we have this house with these roof tiles. Now before proceeding further, let me explain to you what all we did here. This will help you to revise the function of all the nodes that we have placed here. See, the group input node is carrying the information about this cube which we used to create the house in the scene. Then we connected it to the raycast as the target geometry so that the rays of the plane will fall on it, and then we can place these roof tiles as the instance on it. Then we took this hit position socket and connected it to the set position, and we took the is hit socket and connected it to the selection in the instance on points. The use of adding the instance on points was to place the roof tiles as the instances on the rooftop of the house. As a result, we connected this instance socket to the object info node with the circle selected which we used to create these roof tiles. Then moving ahead, we used the join geometry node in order to see both the roof tiles and the house in the scene. Then we added a plane by using the grid node, because in order to use the raycast node, we needed an object whose rays will fall on the house, and accordingly these roof tiles will be placed. Then we connected it to the transform geometry in order to move it upwards, and this was then connected to the geometry socket in the set position in order to connect it to the rest of the node system. Now moving ahead, you can control the number of these tiles from the vertices option here. For example, if I select them and increase it to a higher number like 12, then the number of these roof tiles will increase. And to fix its rotation, I'll go to the instance on points node, and here you have the rotation option. To make it perfectly aligned, we'll be connecting it to the align Euler to vector node, about which we learned in one of the previous chapters of the course. To add it here, press Shift plus A, go to utilities, and in rotation, select align Euler to vector. Let's place it over here and connect the rotation socket to the rotation in the instance on points. Now to control the rotation, we'll be connecting the normal node to the vector socket here. So press Shift plus A, go to geometry, and in read, select normal. Let's place it over here and connect it to the vector. Now let's understand about exactly which axis to align along the vector. So here you can see that the roof tile that we created is lying along the Y axis, and here on the rooftop of the house, in order to keep them straight along the Z axis, we have to align them in the Z axis. For this, go to the align Euler to vector, select the Y axis here, and in the pivot option, select the Z axis. Now what this basically will do, it will align the Y axis of the object along the Z axis. To understand it better, let's first increase the size of these roof tiles by going to the scale option in the transform geometry node, and let's increase it in all the 3 axes to something like 0.12, and to control their rotation, we'll be adding the transform geometry node. So press Shift plus A, go to geometry, and in operations, select the transform geometry. Let's place it after the object info node, and from the rotation options here, you can control the rotation of these roof tiles. So if I rotate it in X axis, you can see that they rotate like this. In order to make them look straight, I'll reduce the rotation in the X axis to a value of somewhere near -60 degrees and the roof tiles look like this right now. And to make it look better, we'll be increasing their number from the vertices option in the grid node. So I'll take the vertices in the x and y axis and increase it to a higher number like 30 or maybe 35, and this is how it looks. Now moving ahead, we'll be adding some windows to the house, and for this go to the geometry nodes editor and add the cube node. So press shift plus A, go to mesh, and in primitives select the cube. Let's place it over here, and to view it in our scene, simply hold down Ctrl plus shift and left click on the cube node. In order to increase the number of vertices in the cube, we'll be using the subdivide mesh node. So press shift plus A, go to mesh, and in operations select the subdivide mesh. Let's place it over here, and you can control the number of subdivisions with the help of this level option, but for now we'll keep it to 1. Now to extrude the faces of this cube, we'll be adding the extrude mesh node. So press shift plus A, go to mesh, and in operations select the extrude mesh. Let's place it over here, and this will extrude all the faces of the cube like this. And to control the extrusion, go to the offset value here and let's reduce it. And now suppose you want to scale down these extruded faces individually and to create an inset effect, and to do this we have to use the scale elements node. To add it in the geometry nodes editor, press shift plus A, go to mesh, and in the operations select this scale elements node. Let's place it over here, but right now if I go to the scale value and try to increase or decrease it, you can see that the scale of entire object is changing. But now suppose you want to scale only the extruded faces, then for this, here in the extrude mesh node, you have the top socket here, and if I connect it to the selection in the scale elements, then now I can control the scaling of only these extruded faces. Now in order to make it look like a window, first let's reduce the extrusion back to 0, and here you can see that we have these faces on the cube, and the size of these faces can be controlled from the scale option in the scale elements. So you can increase it or reduce it as per your own choice. Now since we are making the windows, as a result we need to extrude these faces that are formed here inwards, and to do this we'll need another extrude mesh node after the scale elements. So I will select this one, press shift plus D to create a duplicate and place it over here. But if I try to increase the extrusion from here, you will notice that all the faces will get extruded. But in order to get only the top extruded faces, I'll again take this top socket and connect it to the selection. And now if I change the extrude value, you will notice that these top faces will get extruded like this. Now in order to make the window, I need to extrude these faces inwards. For this, I'll take this extrusion value in this extrude mesh node to a negative number like minus 0.1, and now it looks like this. So whenever you have to extrude the faces inwards, you have to insert a negative value here, and to extrude the faces outwards, you should have a positive value. Now here you can see that these windows are visible on all the 6 faces of the cube. But suppose I need these windows to appear only on this face and the face on the back of it, that is this one. And for this, I need to connect something which carries this information about these 2 faces in the selection socket of the extrude mesh node here. And to do this, I'll be adding 2 nodes. One of them is the normal node, which we even added here and connected it to the align Euler to vector, and the other one will be the compare node. So we'll add it and understand them in detail. So press shift plus A, go to geometry, and in read category, select the normal. Let's place it over here. And to add the compare node, press shift plus A, go to utilities, and in math, here you have the compare node. We'll place it over here, and now let's understand the normal node. So the normal basically means perpendicular of a face. For example, for all the faces on the top of the cube, the normal will be in the direction perpendicular to them, or basically meaning the z-axis. To explain it in a better way, I'll go to the annotate tool and turn on the annotate line. Now see, if I draw the perpendicular to these faces, it means that they will form an angle of 90 degrees with the face, and this is how they will look like. And as you can clearly see, the perpendicular to these faces is in the z-axis. Similarly, for these faces, the normal or the perpendicular will be along the x-axis, and for these faces, the perpendicular or the normal will be along the y-axis like this. And this is the definition of normal. It simply means perpendicular to a face. Now I'll remove these annotations by pressing Ctrl plus Z. Let's go back to the select mode from here, and now this normal node basically acts as an input which is carrying the information about the normals of different faces. And here you have the compare node, and we discussed about it in one of the previous chapters of the course, where I told you that it takes 2 values in the value A and value B and compares them according to the operation selected here. If I select the equal operation and connect the normal to the value A, then it basically means that it will check for each value of normal, and whenever the normal will be equal to the value of B, which is 0, that will be returned as the output from the result socket. And here you can also see the input type to be selected. For example, float, integer, vector. But since we have a normal node here, we need the input type to be vector instead of float. And this is because the normal depends on the directions, that is the x, y and z axis. And you must also have learned this in your school, that vector quantities basically have a magnitude and a direction. And therefore we selected the input type in the compare node to be vector. Now I'll take this normal socket and connect it to the value of A, and here you have the value of B, which you can compare with the normal. And now suppose you want that the window should be visible only on this face. For this you have to check the normal of these faces, and as I already told you, the normal will basically be the the perpendicular line from these faces, and you can clearly see here that the perpendicular of these faces will lie in the y-axis like this. But another thing to check is that if this y-axis is positive or negative, and you can confirm it from here, where you can see that in this direction it is pointing the positive y direction, and if I take my cursor over here, then here you have the negative y-axis, meaning that this side is positive and the opposite side, that is this one, is the negative y-axis. Similarly, you also have other axes like the x-axis and the z-axis. So in case of x-axis, this one is positive and this one is negative. Now I'll remove all this by pressing Ctrl plus Z 6 to 7 times and click on the select mode again. To see the extrusion effect to be applied only on these faces, I'll go to the value B, and here you can see that this one controls the x-axis, the second one will control the y-axis, and the last one will control the z-axis. So I'll go to the y-axis option and change it to 1, and the reason for entering 1 is that it's in the positive direction. If it had been in the negative direction, I would have entered -1 in the y-axis. And now I'll take this result socket and connect it to the selection in the extrude mesh node. And now you can see that these windows or the extruded faces are appearing only on this side of the cube, and this is because of the normal node and the compare node. Now moving ahead, suppose you want that these windows should also appear on these faces at the back. So for this, you can see that the normal is in the negative y-axis this time. So I'll go to the geometry nodes editor, and we'll be creating a duplicate of these nodes by selecting both of them, pressing Shift plus D, and let's place it over here. And this time I'll change the value of B in the y-axis to -1. But if I try to connect it using the result socket to the extrude mesh through this selection socket, then although the windows will appear on this face, but they would disappear from this face of the cube. And that's because the selection socket can only accept one input at a time. And to assign multiple inputs to the selection socket, we have to use another node, which is the boolean math node. To add it here, press Shift plus A, go to utilities, and in math, here you have the boolean math node. So I'll select this and place it over here. Now in this boolean math node, you have two input sockets named as booleans and an output socket which is again named as boolean. And by using this node, I can connect the result sockets of both the compare nodes in the boolean inputs, and if I take the output and connect it to the selection, then this will create a connection between them. But another thing to notice here is the AND operation selected here, and this thing will basically mean that it will check if the result from this compare node and the result from this compare node are equal or not, and only if both of them are equal, then in that case it will give the output. But as we already know that both of these compare nodes are having different values, the first one is having +1 in the y-axis and the second one is having -1 in the y-axis, and as a result, when it compares both of them with this AND operation, the condition won't be satisfied and no output will be given, and that's the reason why you can't see the extrusion effect on any of the faces. And to fix this, we'll change the operation from here, and if I select the OR operation, then this thing will basically mean that first it will check if the normal in the positive y-axis is true, and then it will check the second one whether the normal in the negative y-axis is true or not. And since both of them exist, it will return the output that both of the conditions are true, and therefore we'll be able to see the extrusion effect applied to the faces on both the sides. And this is the use of the boolean math node. Now moving ahead, in order to make this window smaller in the y-axis, we'll go to the cube node which is placed here and reduce the size in the y-axis. So let's reduce it slowly, and at a value of somewhere near 0.2 or 0.25, the structure of our window looks perfect. So in this way we understood about the boolean math node and its working in the AND as well as the OR operation. See, previously when we selected the AND operation, the reason why we didn't get any output is that with the AND operation, it will give an output which will satisfy both the conditions. However, in this case, the first condition was that the normal should be in the positive y direction, and the second condition was that the normal should be in the negative y direction. As a result, both the conditions couldn't be fulfilled simultaneously because both of them are completely different, and therefore we didn't get any output. But with the OR operation selected, it will check both the conditions, that is whether the normal is in the positive y axis in the first case and in the negative y axis in the second case, and will return the output based on which one is true. And in this case, since both of them were true, as a result we got these extruded faces or the windows on both of these faces. Now moving ahead, we'll be placing this window on different faces of the house that we created, and here in the 3D viewport you can also see that the house that we created is not visible, and that's because we are using the viewer node here which is connected to this window. To view the house in my scene, first I'll delete this viewer node by pressing X, and here we have the house in our scene. Let's also connect this extrude mesh node which is carrying the information about the window that we created and connect it to the joint geometry. Now to view the windows on different points or different faces of the house, we'll be using the instance on points node. So press Shift plus A, go to instances and select the instance on points. We'll place it after the extrude mesh node, and since the window object is to be used as an instance to be placed at multiple points, we'll break this connection and connect the mesh socket to the instance socket. But the reason why we can't see anything here is that we have not added any input in the point socket, and here we need to add the input which is carrying the information about this house. For this we'll be using this group input node, and if I take the geometry socket and connect it to the points, then now here we have these windows placed at different points of the house. Now moving ahead, before fixing this house, let's learn about another node which is the mesh boolean node. This node is exactly similar to the boolean modifier about which we studied in this chapter of the course. To understand it again, we'll first add the mesh boolean node here. So press shift plus A, go to mesh, and in operations select the mesh boolean. Let's place it over here, and now here you can see that you have option to add mesh 1 and mesh 2, and here it's also visible that mesh 1 can take only one input, but the socket of this mesh 2 is oval in shape, meaning that it can take multiple inputs. Then from here you can control the operation such as the difference, union, and intersect, which is exactly the same as in the boolean modifier. With the difference option selected, we'll be adding two mesh objects in the geometry nodes editor and connect it here. So the mesh 1 will be a cube. To add it, press shift plus A, go to mesh, and in primitives select the cube. Let's place it over here. Let's also connect it to the mesh 1, and now for the second mesh we'll be adding a sphere. So press shift plus A, go to mesh, and in primitives select the UV sphere. Let's place it over here and connect it to the mesh 2. To view the output here, hold on Ctrl and Shift and left click on the mesh boolean node. Now the reason why you can't see anything here is that by default the size of the cube is set to 1 meters, which is small, and if I change the size in all the three axes to something like 1.25 meters or maybe 1.5 meters, then now here you can see that this strange looking structure of cube will appear. To understand it properly, let me explain it to you with the help of the boolean modifier. For this, let's first bring the 3D cursor on the selected object by pressing shift plus S and select this cursor to selected. Then we'll add a cube and a UV sphere just like we added in the geometry nodes editor. So in the 3D viewport, press shift plus A, go to mesh and select the cube, press G and X to move it here. Now the reason why that structure disappeared is that whenever I do any changes in the 3D viewport, the viewer node will get turned off here, and only that output will be seen which is connected to the group output node here. To fix this, we'll be connecting the mesh boolean node to the group output. So let's connect it here, and now in the 3D viewport, let's also add a UV sphere. So press shift plus A, go to mesh and select the UV sphere, press G and X to move it in X direction and place it over here. Let's enter the edit mode, and to scale up the UV sphere, let's first change the pivot point back to the median point. Then press S and scale it up like this. Let's get back to the object mode, and now to apply the boolean modifier on this cube, first I selected it, then go to the modify properties and click on add modifier. Then in the generate category, select the boolean modifier. Now here you can see that you have three options: intersect, union, and difference, which is similar to the mesh boolean node that we saw in the geometry nodes editor. Here also you can see that we have three operations: intersect, union, and difference. If I again select this cube, and in the object, if I click on the eyedropper and select this UV sphere, then it will basically subtract or remove the part of the UV sphere intersecting with the cube. And to see the changes here, first I need to apply this modifier. So I'll apply it from here, and then if I select the UV sphere and move it somewhere else, then here you can see that this area, or basically the volume of the UV sphere, will get removed from the cube, and the exactly same operation was performed by the mesh boolean node on the cube that we added here. Similarly, you also have some other operations like intersect and union, and if I select the intersect, then only the UV sphere is visible here, and that's because the cube is disconnected here. So if I connect it to the mesh socket again, then a structure like this appears. The reason why it looks like this is that with the insert operation, it will only show that part of the mesh which is common between the cube and the UV sphere. Then if I change the operation to union, then this one will basically join the two mesh objects, that is the cube and the UV sphere, and form a structure like this. And this is how the mesh boolean node works in Blender. Even though I explained you each and every operation in detail, but if you are still having any doubts in it, then you can understand about the boolean modifier, which is exactly the same as the mesh boolean node in this chapter of this course. And now moving ahead, we'll be using this mesh boolean node in order to place the windows properly on our house. But first, let's remove all these nodes which we used for understanding the mesh boolean node. So I've selected all these and press X, and to view the house in our scene, I'll take back this geometry socket and connect it to the group output. Now if I press shift plus A and in the mesh operations, select the mesh boolean node and place it over here just before the join geometry node, then here I can connect two mesh types with the difference operation. So what I'm gonna do is that I'll be selecting this house that we created as the first mesh object and the windows as the second. For this, let's first break the connection here by holding Control button, right clicking and dragging like this. Then for the mesh 1, I'll take this group input socket and connect it to the mesh 1. Then I'll take this instances on points which is carrying the information about the windows and connect it to the mesh number 2. And now let's understand what exactly is happening here. By using this mesh boolean node, we are basically subtracting the geometry of the windows from the geometry of this house. Now even though this is not the final result that we need, but still still it helped us because now we have a clear idea about where we need to place the windows on these faces. We'll be adding a window over this face, similarly at the back face and also at the side faces. So once again this mesh boolean node simply subtracted the geometry of mesh 2, which is the windows, from the geometry of the mesh 1, which is the house. Now in order to place the windows on these faces, we need to add another node, which is the mesh to points node. To add it here, press shift plus A, go to mesh and in operations select the mesh to points, and we'll be placing it just before the point socket of the instance on points. Now what it basically does is that it converts the mesh that comes as the input, which in this case is the house because we have connected the mesh point node to the group input here. And as I already told you, this group input node is carrying the information about the house. But yes, before explaining the mesh points node to you, let me first place all these nodes properly here to avoid any kind of confusion. So I'll select the instance on points node here and place it here. Similarly this one, let's place it here. Let's place this one and similarly select this one and place it here, and this one also. Then let's go downwards and bring this normal node upwards and let's place it over here. Now if I zoom in, you can see here that this group input node, which is carrying the information about this house, is connected to the mesh to points node. And if I change the mode from vertices to faces, then we see some changes here, but to understand them deeply, I will directly connect the mesh to points node to the group output. Now here you see some points added, which are basically placed at the different faces of the house that we created. And this is because in the mode option here, we have selected the faces, but if I change it to vertices, then it will basically place these points on the position of different vertices of the mesh object, or basically the house. But since we want that the windows should be placed at only the faces of the house, as a result, we'll change the mode to the faces. And if I connect the join geometry node back to the group output, then here you can see that our window is placed on all these faces of the mesh object. Now even though these two windows are perfectly placed, the windows at the sides are not perfect, and we can fix this with the help of rotation in the instance on points. For this, I'll connect the rotation socket to the align Euler to vector node. So press shift plus A, go to utilities, and in rotation select the align Euler to vector. Let's place it over here and connect it to the rotation socket of the instance on points. Now as I already told you, we need to input the normal information of all these faces in the vector option here. However, all these faces are having different normal information, and for this you have the capture attribute node in the geometry nodes editor. To use it, press shift plus A, go to attribute and select the capture attribute node, and I'll place it here. Now what this capture attribute node does is that it basically captures the information about the normal of these faces, and that information can be used to rotate these windows properly. So we'll be connecting it in between the group input node and the mesh to points node. So let's place it over here. Now here you can see that you have the data type option, which is selected to float by default, but since we wanted to capture the normal information, which is a vector, so we'll be changing it from float to vector. And also one more thing is that the information that we want to get is about the normal on the faces, but here in the domain, point is selected, which will give you the information about the normals of the points. But here I'll change it to faces, and to tell it that we want the normal to be captured, we need to connect this value socket to the normal. So one way is to press shift plus A, and in geometry go to read and add the normal from here, and the other way is to select this normal node, press shift plus D to create a duplicate, place it over here and connect it to the value socket of the capture attribute node. And now this capture attribute node will capture the information about the normal of different faces of the house object. And now to give this information about the normals to the align Euler to vector node, we'll take this attribute socket and connect it to the vector socket of the align Euler to vector. And now we can align the different axes with the X, Y and Z option here along any other axis which you can select from the pivot option. By default it is selected to auto, and this is how it will align the Y axis of the object, or basically the windows, like this. And since we want them to be straight like this in the Z axis, you should either align the Y axis and set the pivot to auto, or you can set it to the Z axis. Now although this house now has a perfect basic structure, there are still some imperfections in it. For example, the windows that you can see here are also added to the rooftop, which you can't see right now because of these roof tiles, and similarly it's also added here at the base of the house. And to fix this, we basically need to tell the mesh to points node here about at exactly which normal value of the faces we want these windows to appear. And if you remember, we did a very similar thing here in this case when we connected the normal socket to the equal, or basically the compare node, and we used it to compare the normal value to the vector B that we added here. Similarly, in this case, we want that the window should be placed only on those faces whose normals are in the positive or the negative x direction, or in the positive and the negative y axis. Or in simple words, I can also say that we need these windows at all the faces whose normals are not in the positive or the negative z axis. And to do this, press Shift plus A, go to Utilities, and in Math, select the Compare node. Let's place it over here. Change the data input to vector, and to add the normal node, I'll select this one, press Shift plus D, and place it over here. Let's connect it to the vector A. Let's also change the operation to equal and set the value in the z-axis in the vector B to -1. Then to create another compare node with a vector value of +1 in the z-axis, I'll select both of them, press Shift plus D, and let's place it over here and change this value to +1. Now both of them are carrying the information about the faces whose normals are in the negative or the positive z-axis. But since we need the faces which are not in the positive or the negative z-axis, we'll change the operation from equal to not equal. Similarly with this one, let's select not equal. Now another thing to understand here is that the normals of the faces where we have added these roof tiles are not perfectly in the z-axis, and that's because they're not straight like the other faces. You can see that they are slanting like this, and as a result, if I take the annotate tool and change it to annotate line, and if I go to the side view by pressing 3 on the numpad, then the normal of these faces will be something like this. You can clearly see that this is perpendicular to the face, however it is not lying perfectly in any of the 3 axes. As a result, when I'll connect these compare nodes to the mesh 2 points, it will basically mean that these faces will also be included. And to solve this problem, let's first undo the annotations, go to the select mode again, and we need to see only the points of this mesh object. For this, hold on Ctrl Shift and left click on this mesh 2 points node, and this will basically allow you to see all the points of the mesh, or basically the house that we created. Now if I take the compare node and connect it to the selection of the mesh 2 points, then the uppermost point here gets deleted, and that's because it was carrying the information that it must be showing all those points whose normal is not equal to 1 in the z-axis. Similarly, if I connect this one to the selection socket, then the lowermost point will get deleted because this one is carrying the information that all the points must be shown whose normal is not in the negative z-axis. And also here you can see that these 4 points are actually the points lying on the faces of the rooftops. And to remove these, we'll take the second compare node again and connect it to the selection, and here you have the option of epsilon in the compare node. And if I slightly increase it by holding the shift button and dragging it like this, then at one particular point you will notice that those 4 vertices will get disappeared. And now we can connect both the compare nodes together with the use of the boolean math node. So press Shift plus A, go to Utilities, and in Math, select the boolean math. Let's place it over here and connect the first one to the boolean, similarly the second one to the boolean, and take this output node and connect it to the selection. And now here we have only these 4 points, which are actually those points that we needed to add the windows on the house. And yes, the reason for choosing the AND operation here is that we need both of these conditions to be true. The first one is telling that the point whose normal is in the negative z-axis should not be included, and the second one which is telling that the point in the positive z-axis and also those 4 points that we adjusted with the help of epsilon are not to be included here. So both the conditions need to be satisfied, and therefore we selected the AND operation. Now to view the windows on the house, I will delete this viewer node by selecting it and pressing X, and now here we have our house with the windows on all the 4 faces, but not on the bottom face and also not on any of the faces where you have these roof tiles. Now moving ahead to the next topic of this chapter, which is the bounding box node, and we'll be using this node to make our windows look better. Right now you can see that the windows are looking very simple, and so we'll be using the bounding box node to make this structure perfect. But before that, let's understand this node with the help of the Suzanne model that we added here. So I'll select this, and in the geometry nodes editor, here we have the default geometry node system applied. To add the bounding box node, press Shift plus A, go to geometry, and in operations, select the bounding box. Let's place it in between the group input and the group output, and here we see a cube or a box placed around the monkey object. Now to see what actually happened here, let's go to the wireframe mode by clicking on this icon. Now to view both the objects together, that is the bounding box and the Suzanne model, we'll be using the join geometry node. So press Shift plus A, go to geometry, and here you have the join geometry node. Let's place it over here. Then I'll take the socket of the group input and connect it to the join geometry. And now here we have the Suzanne object with the bounding box. So this bounding box node will basically create a box around your object, and that too with the minimum volume such that it completely surrounds the object. So if I go to the front view by pressing 1 on the numpad, then here you can see that our Suzanne model is perfectly placed in this box like this. Similarly, if I go to the side view by pressing 3 on the numpad, then from this dimension also, you can see that the box is exactly covering the Suzanne model. Similarly, if I go to the top view by pressing 7 on the numpad, let's hide this object by selecting it and clicking on this I button. Then from the top view also you can see that this box is exactly covering the Suzanne model. And this is the use of the bounding box node. It will create a box like structure covering your object completely, and that too with the minimum possible volume. Now just similar to the Suzanne model, we'll be using the bounding box node on the windows of this house in order to make the frame of these windows. For this, I'll delete the Suzanne model with this bounding box by pressing X. Let's also delete this cube and the UV sphere which we used to understand about the boolean modifier. So I'll delete both of them, and now if I select the house, then this geometry node system will appear. And so now let's add the bounding box node. So press Shift plus A, go to geometry, and in operations select the bounding box. Let's place it over here. Now we have to place it after that node which is carrying the information about the windows, and that specific node is the instance on points node. If you remember, we added this mesh boolean node in order to subtract the first mesh which was the house and the second mesh which was the window, and at the mesh number 2 we have connected this instance on points node, and so we can say that this node is carrying the information about the windows that we created. So I'll take this bounding box node and connect it over here, and it creates these spaces in place of the windows that we added. And to get those windows back, simply take this instances socket and connect it to the join geometry, and this is the result. If I zoom in, you can now see that we have these frames added because of this bounding box node, and this makes the windows look much better than before. And now it's the time to give some materials to the house and the windows. For this, go to the render view, then go to the material properties and click on the new button. Now the first material here will be basically that material that will appear on the house. So let's change its name from material to house, and let's change the base color to slightly yellow. Now moving ahead, let's create another material for the window glasses. So click on the new button, change its name from here, and we'll rename it to glass. Let's keep the base color to white right now. Then we'll create another material which will be used for the window frame. So I'll change its name from material to frame. Let's also change the base color, and this time I'll keep it to blue color. Now to apply the window frame material, we'll be adding a set material node. So press Shift plus A, go to material and select the set material, and we'll be placing it in between the extrude mesh and the instance on points node. And if I change the material to frame, and now the entire frame along with these window glasses are assigned the frame material. To give some different material to the window glasses, or basically the top extruded faces, let's create a duplicate of it by pressing Shift plus D and place it along with the first set material node and change the material to glass. And now we see that this glass material is being applied to the window frame as well as the glasses, and that's because we have placed the set material node with the glass material after the one where we assigned the frame material. And whenever you have such a situation where two similar nodes are giving different information about the same object, then in that case it will only consider that node which is placed after or basically on the right hand side of the previous one. But in order to assign this glass material only to these windows, or basically these top extruded faces, we have to take the top socket of the extrude mesh node and connect it to the selection in this set material node. And now you can see that this glass material is applied on the top extruded faces, and this frame material is applied to the rest of the window. Now if you remember, while making the glass material, we simply added a white color to the base and did no other changes. But to make it look like a real glass, I'll click on the surface option here and change it to glass PSTF. Let's also reduce the roughness from here, so I'll reduce it to 0. But if you remember, in one of the previous chapters of the course, we created a simple glass material. But the reason why we can't use it here is that in the render properties, we have set the render engine to EV, but that glass material was only for the cycles render engine. And in order to make a glass material in EV, we also have to go to the screen space reflections here and turn it on, and also you have to turn on the refraction. And now to get some proper lighting in our scene, I'll select the light from the scene collection, go to the object data properties, and we'll change the light from point to sun. Let's reduce the strength to something like 5 or 6, then press R to rotate and X to rotate it in the x-axis. And if I move my cursor like this, then now we can see the house that we created properly. Now another thing that you can notice here is that even though we have assigned the glass material to these window glasses, you can't actually see through it. To fix this problem, I'll select the house, go to the material properties, and with the glass material selected, go to the settings option here and change the blend mode from opaque to alpha blend. To see the changes here, we need to view only the windows, and for this, hold on Ctrl Shift and left click on the instance on points node. And now here you can see that the glass material is perfectly applied on these window glasses, and you can clearly see through them. Now press X to delete this viewer node. Now before giving some material to the roof tiles here, let's first turn off the wireframe mode that we turned on previously in this chapter. So click on this drop down menu, and from here I'll turn off the wireframe display. Now to give some material to these roof tiles, first I'll select the bigger roof tile that we created, and in the material properties, click on the plus icon and let's create a new material. We'll rename it to roof tiles. Let's also change the base color to something like orange, and to view the changes here, with this roof tile selected, tab into the edit mode, press A to select all the vertices and click on this assign button. Let's come out of the edit mode, and now you can see that the color of these roof tiles has changed. But another thing that you can notice here is that the yellow color of the house is also appearing on this lower part of the roof. And to fix this issue, we'll add a set material node by pressing Shift plus A, go to material and select set material, and we'll be placing it in between the node connection of the group input node and the join geometry. So let's place it over here. Let's zoom in and we'll change the material to house. Then I'll create a duplicate of it by pressing Shift plus D and placing it over here, and change this material to the roof tiles. But as I told you earlier, the one that is present on the right hand side will only be seen as the result. But in order to apply this house material only to the side faces, then for this we have to tell the set material node that we want to apply it only on those specific faces whose normal lies on the positive and negative x-axis or on the positive and negative y-axis. And if you remember, we created a system of nodes with the normal and the compare nodes which were serving the same purpose. So if I take the boolean socket here which is connecting both of them and connect it to the selection, then now you will see that the house material is getting applied only on the side faces and not to the rooftop. Now in order to see the glass material properly, to ensure that you have this ray trace refraction option turned on. And now we have a simple yellow color applied to this house, this blue color applied to the window frame, and the faces in between the window have been assigned the glass material. But the reason why you can't see anything inside the house is that the face behind this window is also having the yellow material that we assigned to the house. And to fix this issue, we'll be creating a transparent material and we'll place it after the bounding box node. So go to the material properties, click on the new button, let's create a new material, and to make it transparent, change the surface to transparent BSDF. Also, because we are in the EV render engine, so change the blend mode from opaque to alpha blend. Then to assign the material, select a set material node, press Shift plus D and place it after the bounding box node. Change the material to the material.001 where we created the transparent material. So I'll select this. Now to see the result, I'll go to the mesh boolean node, hold on Ctrl Shift and left click on it, and now here you can see that these faces are now having the transparent material. But if I delete this viewer node, you won't be seeing the same thing here. And the reason for this is the set material node that we added here. Since in the selection socket it is carrying the information that it has to apply this house material, or basically the yellow material, to all these four faces, as a result it's also applying this yellow house material to the face behind the window. And to fix this problem, instead of connecting it in between the group input and the join geometry, we'll connect both of these nodes in between the group input and the mesh boolean node. I'll select the first one, press Shift plus D and place it over here. Then I'll delete it from here. Similarly, I'll select the second one, and yes, instead of creating a duplicate, you can also remove it by holding the Alt button and left clicking on it. Now I'll place it over here, and again I'll take the boolean socket of the add node and connect it to the selection in the set material node of the house material. And now you can see here that you can easily see through the windows of this house because the face at the back of them is having a transparent material. Now moving ahead, let's finalize this house and fix some minor issues in this house model. So I'll go to the solid view again. Now the first thing to notice here is that the tiles are not properly placed. For example, you can bring them down to make it look better. And to do this, we have to select the tile in our scene, tab into the edit mode, press A to select all the vertices, and if I press G and Y to move it in the Y direction, then you will notice that these roof tiles will also begin to move like this. Let's fix this position, and now our roof tiles are looking like this. And let's come out of the edit mode. And now another thing that we can fix here is the tiles appearing on the top here. And to solve this problem, I'll go to the geometry nodes editor, and if you remember, we created these tiles with the help of this raycast node. Now we'll be using the math boolean node in order to tell the instance on points node here that it does not need to add any tiles on this face which has a normal pointing towards the positive z axis. And to do this, press Shift plus A, go to utilities, and in math, select the boolean math. Let's place it over here. Then press Shift plus A again, go to utilities, and in math, select the compare node. Let's place it here. Change the input type to vector since we'll be adding a normal node. And to add that normal node, press Shift plus A, go to geometry, and in the read category, select the normal. Let's place it over here. Now we'll connect this normal to the vector A, then I'll change the operation to not equal, and we'll set the vector value in B to 1 in the Z axis. Now I'll take this result socket and connect it to the first boolean input, and for the second boolean input, I'll take this isHead socket and connect it here. And now to see the output, we'll be connecting this boolean output socket to the instance on points here. So I'll take this socket and connect it to the selection. And now here you can see that the tiles at the top of the face have disappeared, and now our house looks perfect. But let me show you another thing. If I tab into the edit mode, and if I press 3 for the face select mode and select this face, then I can extrude it like this, and it will automatically add these windows at all these side faces. Similarly, if I select this face and press E to extrude it, then in this case also it will add a window here and also some roof tiles. The reason why the number of roof tiles is less is that here in the grid option the size is very low, but if we increase it from 4 meters to something like 100 meters, let's also increase the vertices from 35 to a very high number like 400, or maybe let's increase them to 500, then this is how it looks. To see it properly, let's come out of the edit mode and turn on the render view. And now this is how this house is looking right now. And to fix these issues like the placing of the tiles, you simply have to change the values in the size option and the vertices option. For example, if I take the size values and reduce it to something like 80, then it looks like this. Let's also change the number of vertices in the x and y axis, and if I increase it to something like 550, then it looks like this. And if you want to change the scale of these tiles, then you can go to the transform geometry node and change the scaling from here. But right now, I think that the house model looks perfect, so let's finalize it. And we'll also be adding a plane below it by pressing Shift plus A. Go to mesh and select the plane, tab into the edit mode, press S to scale it, and to move it downwards, press G and Z, and let's place it over here. Let's also scale up this plane slightly more by pressing S, and I think that we should scale it up 10 or 20 times, so I will press 20 and press enter. Then go to the camera view by pressing 0 on the numpad. Let's also come out of the edit mode of this plane, and to change the camera view, you can either click on the lock button here, or you can press N, and in the view section, turn on the lock camera to view. Now let's change the view of the camera to that particular position where the house is completely visible, and that too from a perfect angle. So here I think that it looks perfect, so let's finalize this. And to hide this bigger tile, I'll select this and click on this I button, and if you don't want it to appear in the rendered version also, then turn off the camera icon from here. Similarly, we also hided this plane in our scene, so I'll click on the camera button here also to hide it in the render view. Now to give some material to the base or the plane, we'll be assigning the sand material to it, which we created in this chapter of the course. To add it here, first we need to open the asset browser, so click on this icon, go to the asset browser, then change this to the user library, and now here we have the sand material that we created. So I'll select this and drop it on the plane. And yes, one more thing that I noticed just now is that this window of the house is colliding with the roof, and to fix this issue, I'll select the house, tab into the edit mode, and with the upper face selected, press G and Z to move it upwards. Let's move it up like this, and here it looks perfect. Let's come out of the edit mode. Let's also adjust the camera view, so I'll zoom out and adjust the camera like this. Now you can also try to change the color of this house, or maybe try to add some different materials with different types of roughness, metallic nature and other things, and also you can add some more lights in the scene in order to make it look better. And I also did some basic changes in the material and the lighting, and this is how the final rendered version looks. And also this brings us to the end of this chapter. In this chapter, we learned about lots of geometry nodes and their usage, and if you're learning them for the very first time, there is a really very high probability that you can't understand all of them by simply watching the video once. So a better approach will be to either rewatch the whole video again and then make the model, or else rewatch that particular part where you think that your concept is not clear. And so our next chapter will be the chapter number 37, geometry nodes creating a donut. So don't forget to subscribe to our channel, press that notification bell so that you can get timely updates about the upcoming chapters. Thank you for watching, and we'll see you in the next one.